Welcome to Real GMAT Problems, episode 36. Doing real GMAT problems is a very efficient way to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition is out of print, and that's partly why I'm going to go through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to cover. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be quite similar to what you're going to see on your official exam. I'll give you a chance to work through the solution on your own if you'd like, and then I'll discuss my thoughts on what to take away from each one. I recommend pausing after I read through each problem and trying to solve it. At the very least, try to visualize how you would solve it if you're on the go. You might not be able to execute all the steps in your head, but just do your best. It's a great mental workout. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. So let's start with a warm-up problem, and then we'll explore some more complicated questions that build on a few of the central concepts. First problem says, a retail appliance store priced a video recorder at 20% above the wholesale cost of $200. If a store employee applied the 10% employee discount to the retail price to buy the recorder, how much did the employee pay for the recorder? I'll read that again. A retail appliance store priced a video recorder at 20% above the wholesale cost of $200. If a store employee applied the 10% employee discount to the retail price to buy the recorder, how much did the employee pay for the recorder? Option A, $198. Option B, $216. Option C, $220. Option D, $230. And option E, $240. Again, recommend pausing here because I'm just going to jump right into the solution. It's a great warm-up problem for a few reasons. As usual, the math itself isn't horrific if you're solid on the basics, but if you're not, we've got the math basics of fractions and percents linked for you below, so you can reskill with those right away, and feel free to return here when you're ready. Also, it's a good way to get comfortable with how you're organizing your thinking and what you're writing down to make more complex questions a little bit easier to solve. Let's start by writing what's given and asked, as I typically recommend, and then we'll go from there. So we want to know how much the employee paid. We bought the recorder for $200, priced it at 20% higher than that. One of the employees, though, then applied a 10% discount to that price. And this is a good opportunity for some columns. The problem isn't that complicated, so we might not end up with more than one row, but that's fine. There's still a lot of value to be gained from building the habit of being visually organized in general, which you've probably heard me say quite a few times if you've been following the series for a minute. And using rows and columns when you have comparisons of any kind in a word problem is a really good bet. So in this particular situation, we've got old price versus new price. We've got retail price versus discounted price. And those are great situations to be thinking rows and columns, even if there's only one row. So I'd probably write a column that says something like cost, and then I'd write 200 under that. To the right of that, I'd probably make a column that's labeled price, and then I'd write something like 120 over 100 times 200, or increase 20%, or 20% higher than cost. Whatever makes sense to you there works. And then to the right of that, I'd make a column that says discount or something similar, and then I'd probably just write 90% of the price or decrease by 10%, something to just help me recall exactly what to do when I get to that step eventually. At that point, we just need to execute the math well, and we should be good to go. So let's go ahead and do that. You've probably heard me recommend using fractions for percent calculations in the past, so that's what I'm going to do here. Of course, if you're never making mistakes with your percent calculations using decimals or some other method, then by all means keep doing what you're doing. But if you're a little shaky on your percent execution, then fractions should really help eliminate any mistakes you're making. So I'd write 120 over 100 times 200 over 1. That just helps me see better what I can and can't cancel from the numerators and denominators. Again, if it's been a while and you're just starting out, since you've canceled anything from a fraction, check out those math basics episodes for you. Bring you right up to speed. And let's just cancel the zeros in the top and the bottom of the fraction. And that should get us 12 over 20 when all is said and done. From there, you can do long multiplication if you want to, or you may have memorized that 12 times 20 is 240. Sorry, I think I might have said 12 over 20, but it should be 12 times 20. My apologies there. So we should get 12 times 20, and 12 times 20 is 240. Side note, it's a great idea to memorize your times tables from 1 to 20. I'm fairly certain I've recommended that previously. Most people just learn up to 10 or 12 as kids with times tables, but on the GMAT, it's generally really useful to know that 15 times 15 is, 225 or similar from memory. Anything like that, 15 times 17, 15 times 19, that's not stuff that adult working professionals are usually thinking about on a day-to-day basis. So um, it's really helpful to do a little bit of memorization, and it doesn't come up a ton, but when it comes up, I think it's a big emotional win in the middle of the exam, which a lot of times is bigger than just getting that particular question right. Obviously, there's a lot of value in getting the question right, but just having those emotional wins can help insulate you from the stress that I think is inherent in these exams. So just a suggestion, it's not crucial, but for sure, if you're going for a higher score, like above the 90th percentile, I think you'll find the values definitely there. Like I said, you could just do long multiplication. Um, if you want an elite result, usually elite effort is a good bet. Elite effort is a good investment. So now we know the retail price is $240, and we can apply the 10% discount there. I think it might be easier to calculate 10% and subtract rather than doing the math for 90% of the number. Both work, obviously, but I'm going to just pivot instead of what I wrote down in my column of 90 over 100 times the result. I'm just going to do 10% of the result and then subtract that away. So 10% of 240 is 24. That's a little bit easier for me to do than 90% of 240. And 240 minus 24 is 216. So again, feel free to use long subtraction there if you like, and if you struggle with computation mistakes. And 216 is our correct answer, which also corresponds to option B, as in beta. And interestingly, it doesn't look like there's a big trap answer with a lot of gravity on this one. So the best tip that I can give, beyond what I already shared about just staying organized and a lot of the basics that you've probably heard me speak about before, is that it's usually best for most people to do those percent and decimal calculations as fractions. It might seem like a small thing, but it's usually a big thing. And it's also really easy to sweep those mistakes that might happen as a result of bad decimal math or rushed computation of any kind, really. It's just really easy to sweep those under the rug and just tell yourself like, oh, I'm never going to do that again. But deleting negative habits usually is not that simple. It usually doesn't work like that. It usually takes a significant amount of energy, and it's usually best to replace the old habit with a new, better habit. That's the thing that I've seen work the best, rather than trying to fix the old habit of like, oh, let me just do my decimal computation better. That definitely can work. But the suggestion I'm giving here, just to be crystal clear, is think about like what's a new thing that I could do. That would mean I don't even have to worry about the old habit. The old habit's just immediately gone if I do the new habit. That's usually the easier, faster way to success there. It's still good to be familiar with decimal math, just to be clear, and we've got math basics material on that for you linked below as well. But I found people tend to make fewer mistakes when using the fractions. It's that visual thing of being able to do it on the scrap paper, visually cross out the zeros, that kind of stuff. And you'll probably see that come up over and over, since percent word problems are basically the most common question in the quant section these days. But that's really the long and short of that question, and probably the best advice I can give you there. The hit rate for us as a group with that question is pretty high, which is why I chose it as a warm-up question. But it also does introduce some interesting themes that I think you'll find valuable for the next question. So if there's anything you want to remember from that one, I'd recommend just pausing and making like a note to self right now, or just send yourself a quick text or email to note it later, and then we'll build on those concepts with a couple slightly more complicated examples. Again, feel free to pause. I'm just going to jump right into the next question. Question says, a tank contains 10,000 gallons of a solution that is 5% sodium chloride by volume. If 2,500 gallons of water evaporate from the tank, the remaining solution will be approximately what percent sodium chloride? Again, a tank contains 10,000 gallons of a solution that is 5% sodium chloride by volume. If 2,500 gallons of water evaporate from the tank, the remaining solution will be approximately what percent sodium chloride? Option A is 1.25%. Option B is 3.75%. Option C is 6.25%. Option D is 6.67%. And option E is 11.7%. Again, recommend pausing here, getting as far as you can. It's a good follow-up question. It's a little bit more complicated, but also a lot in common with the previous problem. In fact, 4 times as many of us missed this question versus the previous one. So let's see if we can build on some of those principles and keep you from getting something like this wrong on test day. As usual, I recommend writing what's given and asked so you don't miss anything critical in your setup. And it looks like about 8% of us end up getting turned around there and winding up with option B as a result of getting turned around there, which is unfortunately not correct. So let's try to head that off with some good organizational habits. We want to solve for the percent of solution that will be sodium chloride after 2,500 gallons of water evaporates. So I'd probably just set that up as a fraction with some half math, half English notation, something like literally written out the words sodium chloride and then a fraction bar underneath that, and then right under that, literally writing out the words total remaining water. So it's not totally math, but it's not just totally pure English words. And I've found that with word problems in particular, that's a really good intermediate step if you struggle with the translation part of word problems. I'll have more about that, more to say about that later. But if you search the feed for word problems or word translations, you'll get a lot of great examples where just that half math, half English thing, as simple as it is, can really be surprisingly useful for folks. So highly recommend that if you struggle. If you're not struggling, obviously keep doing what you're doing. And let's explore using that half math, half English thing a little bit for what's given as well. So I'd probably write something like 10,000 gallons, like the number 10,000 and the word gallons, and then a multiplication symbol, and then 5%, and then the word sodium chloride. So like half math, half English there. And then I'd write something like remove 2,500 gallons. Things like that tend to work really, really well. And it might seem like you're not really making progress or you're not like doing math the proper way when you're doing stuff like that. But that intermediate step, it allows you to capture the logic of the problem. And if you can capture the logic of the problem, you can usually express it mathematically well. If you gloss over that logical step, making sure you understand how the quantities are interacting and what the objective is, a lot of times you'll make a mistake in the setup and do a lot of correct math on that mistake. And if you've been studying for a long time, you've probably seen that. So just trying to help you get ahead of that. That was a big problem for me back in the day, for sure. It's probably not a game changer to write that way on a problem like this particular problem, but it can be. And a lot of folks find it really helpful as word translations get more complicated. So if you find yourself really struggling with the complex word translations, even if the simpler ones are easy for you, then just try out that half math, half English thing and see if it helps. Now that we've got the logical elements of the problem captured, let's start to put that into mathematical terms and solve. Rather than making like a grand equation that includes everything, this seems more like a problem where I can just solve one step at a time. And that's very similar to the previous question. Like I'll just walk through each step of the math as it's presented to me. So I'll start by finding out what 5% of 10,000 is. Again, I'll just use fractions so I don't make a mistake. I'll write 5 over 100 times 10,000 over 1. And I'll cancel all the zeros, and that'll leave me with 5 times 100, which is, of course, 500. And I'll make sure to label that as gallons of sodium chloride so that I don't get mixed up down the line in the problem. And again, if you're good on the setup, well, I guess not again. If you're good on the setup, but then you tend to fumble things as you're doing calculations and you kind of lose track of what's happening in the question, or you lose the plot as you're going through the problem, simply labeling things with units as you solve for them can be a huge help. I know these are like really simple tips, but a lot of times it's the simplest strategy. That's the one that's easiest to implement under time pressure, and that's part of the reason it works so well. So the good news is that the numerator of the fraction that I'm looking for is 500. I just solved for that. So now I just need the denominator. That part's pretty simple because I started with 10,000 gallons and then I just had 2,500 evaporate. So 10,000 minus 2,500, that's 7,500 gallons. And that's my denominator right there. Now, again, I guess it's only simple if you've set it up right. If you make a mistake, then things can get real complicated real fast. I guess that's an important point. But I'm looking to take the fraction of sodium chloride over the total remaining gallons of water and convert that to a percent. So I've got 500 gallons of sodium chloride, and then I'll write that as the numerator of the fraction. And on the bottom of the fraction, I'll have 7,500 gallons of water. And I'll just cancel some zeros to get 5 over 75. There's plenty of ways to calculate 5 over 75 as a percent, but for me, I found it easiest to reduce it as far as I can and then just use long division. So that's what I'm going to do here, but again, plenty of ways if you don't like this way. 5 over 75 reduces to 1 over 15. A good advertisement for memorizing times tables there again. And again, we've got a whole series in the Math Basics program about how to do long division well, especially with decimals. So I'm going to gloss over all the specific math there. And if we did 1 divided by 15 with long decimal division properly, we'd get 0.066666 repeating, which would lead us to option D, as in delta, which is 6.67%. So that's one potential path to the correct answer. What about the traps? Why are so many of us missing this one? Well, I mentioned earlier, a lot of folks go for B, which is 3.75%. And I think what's happening there is that people are thinking in this like really clever way, which is we're scaling down the amount of water by 25%. So 10,000 minus 2,500, that's removing 25% of the water. But then I think people are incorrectly thinking that the sodium chloride is going to scale down the exact same amount, because 5% scaled down by 25% is 3.75%. But if you think about it, even though that's really, really clever, it's not what the problem's actually saying or asking. So that's what I was getting at before with like the advice I'm giving you is like maybe comically simple. Like, what is this guy even talking about? Like, why does this guy have a podcast about writing stuff down on GMAT problems? This is absurd. And that's how I thought at the beginning too, everybody. Like I just thought the whole exam was about knowing the material. And I couldn't really blame myself for that because pretty much every test I had ever taken up until that point in my life was just if I knew the material, I'd do well, and if I didn't know the material, I wouldn't. And so it's super easy to assume this test is the same way, and that is true for like a very, very small percentage of people. And you might be friends with those people, and so those people might be saying to you like, "Hey, what's the big deal? Why are you struggling with this test, man? Just study the stuff, you know?" And I just want you to know that if you are struggling, like you're not alone. 99.5% of people struggle with the exam. It's harder than they think it's going to be. And yeah, that's why I'm here to help and give this advice that might be like embarrassingly simple. But again, I think if you've been studying for a while, you'll be like, wow, like I probably should do that. So, um, it's just part of the reason you've heard me emphasize the comprehension and organization pieces so much is like you have these really intelligent people coming up with this really clever solution to this problem of like, oh yeah, I'm just scaling the solution, no big deal. And it's just such a big bummer when you invent a great solution to a problem that you're not actually being asked on the exam. So just trying to help you avoid that. Interestingly, many of us go for option C, which is 6.25%, and I think that's probably just a math error. So in addition to the tips I just gave, I'll also recommend working on your decimal long division just a little bit so that it's there when you need it. It's not something you're probably going to need to be doing an hour a day for the next month. That's super unlikely that you need to practice that much, but I think like putting at least an hour total into it could make a lot of sense. And then you've probably got what you need. Like it's not something you're going to use a ton on the GMAT, but when you need it, if you're rusty on it or you're not comfortable with it, that can lead you to answers like C. And yeah, I think there's a large percentage of us going for C. Let me double check. I think it's 7% of us pick C, which is like, if you think about it, that's real close to the right answer. Yeah, 7% pick C. And that hurts. That hurts. I don't know if it hurts as much as picking B. Um, but yeah, that's just why would we do that to ourselves? You know what I mean? Like I think that's a good way to think about it. So, a little bit of practice with long division and decimal long division goes a long way. Again, we've got a whole pod episode on it for you, linked below. And you can even use a little bit of Gen AI if you want some practice problems or just a web search. I'll get you some good decimal long division practice problems. I mean, probably between 10 and 50 maximum would be like more than enough. So again, if you're not feeling rock solid on your approach to decimal long division, check out that math basics episode. Do a little bit of practice, and that should greatly increase your odds of success on a problem like this one. It's probably more than enough for that one. So as always, I just recommend pausing and making a note to self if there's something you want to remember there. And whenever you're ready, let's jump into one final problem with a lot of similar themes. The problem says, from January 1st, 1991 to January 1st, 1993, the number of people enrolled in health maintenance organizations increased by 15%. The enrollment on January 1st, 1993 was 45 million. How many million people to the nearest million were enrolled in health maintenance organizations on January 1st, 1991? I'll read that again. From January 1st, 1991 to January 1st, 1993, the number of people enrolled in health maintenance organizations increased by 15%. The enrollment on January 1st, 1993 was 45 million. How many million people to the nearest million were enrolled in health maintenance organizations on January 1st, 1991? Option A is 38. Option B is 39. Option C is 40. Option D is 41. And option E is 42. Again, I recommend pausing and solving. So another good follow-up here, since about 50% more of us missed this question than the previous one. So 18% of us missed the previous one, and about 26% of us missed this one. So clearly there are some challenges under the surface. Again, let's give you some tools to help you perform well. Writing what's given and asked again, I would probably use some column headers. So very similar themes. One would be 1991, one would be 1993, just to keep things simple. Again, we've got a clear comparison here. Last year versus this year, or 1991 versus 1993. Very, very common. Under 1993, I would write 45 million. I'd probably write something like 45M just to avoid writing 6 zeros there. And under 1991, I would probably start by writing question mark M or something like that, just as a placeholder. That's what I'm trying to solve for. And then I would somehow depict that there's a 15% increase from the unknown value in 1991 to the known value in 1993. Something like an arrow from 91 to 93 with a plus 15% written next to it. Anything simple and clear works really well. At that point, I've got the logic captured, like I was talking about before, so I can start filling in the mathematical details. But there's definitely a lot of risk if you feel like you're always going to try to do the math too soon and you find yourself making the kind of mistakes that I was talking about in the previous problem. That's a good opportunity to add that intermediate half math, half English step. Make sure you're making rows and columns when there's comparisons. And that should be all you need to get the logic pinned down first, and then the math should follow naturally from that. So the key here, as it is in many GMAT percent word problems, is that we're increasing an unknown amount. And the result of that increase is given to us in the problem. So in this case, the result of the increase is 45 million. So we need to increase the unknown amount by 15%. And for whatever reason, a lot of folks just struggle with that. And I think that's probably part of the reason we got over a quarter of us missing this one. If you're not already sure how to express that mathematically, you can write something like 115 over 100 times x, an unknown, equals 45. There's plenty of other ways to express that. We've talked about quite a few of them actually. So if you're interested in that, just search the feed for percents and you'll find some good examples. But I already mentioned how much I recommend using the fractions as the percent computation. So we're just going to run with that for now. At that point, we've just got an algebra problem, which is great news. So let's go ahead and solve by multiplying both sides of the equation by 100 over 115 to get rid of the fraction on the left. That gets us x equals 45 over 1 times 100 over 115. And I'm going to leave out the millions because the question specifically says that the answer is in millions. And so as long as I get the two-digit number right, I'm going to be good to go. And I can just ignore those 6 zeros. It makes things a little bit easier to look out for me. So I'd probably reduce the 100 over 115 since both are divisible by 5. And again, don't be afraid to do some long division there to avoid mistakes. But if you've memorized your times tables, you would know that that's 20 over 23. And now we would have x equals 45 over 1 times 20 over 23. Again, you can handle the math however you like, but notice how close the answer choices are to each other. We got 38, 39, 40, 41. That's a time where precision is going to be really helpful rather than like a very broad estimation. And in any question that says approximately or closest to or something where they're inviting you to estimate, it's a great idea to just check the answers and see how far apart they are. If they're quite far apart, then you can often estimate very aggressively. But if they're close together like this one, it's usually good to use something more mathematically precise. In fact, we saw that in the previous problem, and those answers are even closer to each other than these ones are. So that's part of the reason I was favoring long division on the previous problem, and that's part of what's going to lead me to favor long division rather than a quick estimate on this one also. It's not the greatest news, since I would prefer a quick estimation, but I guess if the price of getting my dream MBA and having my dream career and probably living my dream life as a result is some long division, then that seems like a pretty good trade. So I'd probably do multiplication on 45 times 20 on the top of the fraction to get 900. And then I'd just set up my long division as 900 divided by 23. Again, just going to gloss over the details because I've done a truly tremendous amount of long division on the pod. And all the math basics lessons are there if you would like some upskilling. Let's assume I do my math properly. And that gets me to 39, which would get me to answer B as in beta, which is the correct option. And on the surface, I don't think that problem looks much more complicated than the previous one, which is interesting because, like I said, 50% more of us miss it. So let's try to dig into why that's happening. Looks like about 13% of us choose A, which is 38, and then about 9% of us choose C, which is 40. So those numbers that are directly above and below the correct answer. And similar to C in the previous problem, I think that indicates that people are just doing the math wrong. Like they're getting really close to 39, and then they're either estimating too quickly or too aggressively, or they're just making a straight up mistake in the math. So while typical errors on questions like this are more organizational, like solving for the wrong element of the problem or not capturing the logic like I was talking about, this one actually looks like most of us get it set up right and then just fumble the numbers, which again, it just hurts. It's just so painful. So that's a strong endorsement for the recommendation I made on the previous question, which is just work on your long division skills enough. You don't even have to like work on them a lot, just work on them so that they're sufficiently good. And in the previous one, I was talking about decimal long division, which people are generally worse at than regular long division. But apparently, regular long division is a struggle on this problem for a lot of us as well. Not trying to call anybody out here. I struggled with it too. But I'm trying to make the point that it's a simple fix. So I would say probably not something you need to be doing 2 hours a day, but it might be something that's worth putting a few hours into until you feel rock solid with it. Having said all that, it does bring up one final issue that I have found to be pretty common, which is that people know how to do the long division properly, but they just don't execute well all the way to the end of the problem. And that's understandable. We all get fatigued. As a group of people, we're probably way more fatigued than most people because we're generally working intense jobs. We like to do a good job, so we're usually working intensely at those intense jobs, and then we're studying for a really intense exam on the side or on top of all that. And those kinds of things can definitely wear you down. So it's okay to give yourself some grace when it's warranted. But it's also a good idea to ask yourself whether what you're doing during your studies is acceptable behavior to you, given your own goals. Again, I'm asking you to self-assess here. I'm not judging anybody, just asking you to ask yourself that question. For example, none of us want to work with quote unquote dreamers who like can't get things across the finish line, if that makes sense. So people who have the big ideas and they're like, we're gonna do this, we're gonna do that, but like they're never actually getting results. None of us want to work with those kinds of people. And so obviously we don't want to be that kind of person. And I've said this in the past, but I'll say it again. Having a moment of weakness does not make you a weak person. We all have moments of weakness. Like I said, we all get fatigued sometimes, but always behaving in weak ways definitely makes you a weak person. So don't accept that from yourself. What we tolerate, we tend to invite more of. So it's like an important truth for most of us. At the same time, if we look at the flip side, it can be almost impossible to work with people who have totally unrealistic expectations, such that people are always going to be perfect 100% of the time. So we don't want to become that person either. So usually the ideal is between those two extremes, and it can be a challenge to manage ourselves well within those parameters. Now, one thing I've found that's interesting is it's okay if other people think that your expectations are unrealistic. Not everybody is going to agree on that, and a lot of people just want you to take it easy on them, which is sometimes the right thing, but not always. And I think that the key is that it doesn't really matter if other people think your expectations are, well, it can matter in many situations if other people think your expectations are unrealistic. The key is that your expectations cannot be unrealistic. Okay. So that goes beyond just betting against consensus and borders on insanity. So we don't want that. So just to try to put this into practice and give you some tools, my advice is don't let yourself finish problems in a weak way. If you started the problem strong, it doesn't matter how tired or frustrated you are. You should do everything you possibly can to execute well all the way to the finish, all the way to the last step, even if that means taking a break mid-problem to regain your composure and make sure that what you're writing down reflects how serious you are about this process and being successful with it. And that's because fatigue is part of the exam. And generally fatigue is part of doing most things well. So it's worth building the skill of performing well when you're fatigued. And this will help with you because this helps you isolate the thing you can control in the situation, which is your own effort. You can't always control what's happening around you. You can't always control your circumstances or your stress levels or how fatigued you feel. Obviously, we should all try to control those things as much as we can, but that's not the point. The point is that even with your best and even superhuman effort, sometimes we may not be able to control all those things all the time. But the thing you can always control is your effort. And it's good to think about your effort that you're putting into the problem and finishing strong, kind of like a muscle, because the more you allow it not to flex, and the more you give in to whatever the voice in your head is telling you about why it's okay to not put forth the maximum effort, like that voice that's constantly negotiating with you against your commitments, then the weaker that muscle is going to get. But the good news is if you practice using that muscle, then it gets stronger. If you're just starting out, it might not be that strong yet. That's okay. I started with really weak in that department, and it took me a long time to get it strong enough. But obviously, I was able to do that, and it's been really, really helpful. Like I said, you want to give yourself grace when it's appropriate, but don't accept not trying. That's super unlikely to get where you want to go. Okay. So the phrase I like to repeat to myself is a quote from Michael Jordan. He used to say, I can accept losing. Everybody loses sometimes, but I can't accept not trying. And Michael Jordan was arguably the person who was the best at his job that anyone's ever been at their job. And so he's a good authority on effort. Now, the flip side of that is if you start a problem and it's clear that you're not in a good headspace and you're not going to be able to execute well, then it's probably best to just pause the study session and take a break rather than trying to push yourself to finish strong, even though you started it like not so strong. And that's a good way to make the decision because it's not always easy to make those decisions when we're fatigued. It's like, should I push or should I take a break? These are it seems easy and obvious from the outside, but it's not always easy and obvious when kind of the fog of war sets in and you're in the trenches, so to speak. Um, the reason for this advice I'm giving you is a lot of the thoughts and actions that lead to great results on the exam are habitual, meaning that you want to practice in a way that encourages you to think and act in the optimal way for test day. And the more you practice those thoughts and those actions, the easier it's going to be to keep doing those thoughts and actions. And the more you practice without those thoughts and actions, then the more difficult it's going to become to integrate them when it counts. So that comes back to the it's like a muscle. The more you use it, the stronger it gets. So it's going to be really disruptive to your practicing when you don't have the physical or mental resources to execute well. So it's all about how did I start the problem? So if I started the problem strong, I want to force myself as much willpower as I can muster to finish strong. If I'm unable to start the problem strong and I'm really struggling and spinning my wheels there, then that's probably a time to take a break. And I'm meaning in terms of execution. If you don't understand something in the problem content wise, you can probably dig into that. But that's kind of obvious. I'm talking more about like how do you know if you're too tired, basically. So you want to give yourself some grace when you're having trouble starting problems strong. So despite even the best effort, the body has limits, and those limits can be grown and expanded, but they'll probably always be there. So it's best to respect those limits and grow them responsibly over time, rather than just trying to bulldoze all the limits with this sort of irrational hope that we can sometimes get that we're going to somehow create lastingly great results by doing that. That's usually not the case. Lastingly great results usually come from making steady investments over a long period of time, or at least regular investments. So once again, I'll just tie this off. I probably talked too much about that. Sorry if I did. Just trying to be helpful. If you can start strong, force yourself to finish strong. If you can't start strong, then just force yourself to take a break, even coming back the next day if needed. So, difficult topic to address there, but I hope it helps. It's not an easy thing to be on point 99% of the time, but it is doable. So it's definitely worth pursuing. And if you want some help with that, check out our episodes on consistency, on how to study smarter, harder, and longer, our episode on motivation, and our episode on discipline. And we'll link all those below for you. Again, if there's any notes to self to make there, then I'd recommend making those now. And feel free to pause if that would be helpful. If you have questions about anything we've presented here, you can reach us at the GMAT strategy on current social channels, or you can email us. Our email address is contact, CONTACT, at thegmatstrategy.com, and we'll do our best to help out. None of this is medical advice or psychiatric advice, just to be clear about what I was talking about before. If you're really, really struggling with mental or physical fatigue or problems, then definitely get professional help. But if you are in good health, then I think all the advice that I just gave applies. And as always, my greatest hope is that this material is going to make your studies as easy and as painless as they can possibly be. If you want more tips and more strategies for optimizing your performance on the GMAT, just head to our website, thegmatstrategy.com, and I recommend checking out our video presentation on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everyone. Talk to you soon.